Hello dear students, once again welcome back to our channel. In this video we are going to continue exercise 6.5. We can start with the problem number 6. Okay, here triangle ABC is an equilateral triangle with a side 2A. Find each of its altitudes. Each of its altitude means we know that a triangle has how many altitudes? 3. By definition, what is an altitude, children? It is a perpendicular line segment from a vertex to its opposite side. Being a triangle has 3 vertices, you can draw 3 perpendiculars. Okay. But here very important point is, being it is an equilateral, all these 3 altitudes will have same length. Okay, from B to AC, from C to AB, from A to AD, all altitudes will have the same length because the triangle is equilateral. And one more additional concept, that means for an equilateral triangle, median as well as the altitude will be the same. Understood, children? So here what we need? We need one of its altitude. So I have drawn one altitude AD from the vertex to its opposite side BC. Understood? Figure is clear? Okay. See, being it is perpendicular, that means here angle ADB and angle ADC, that side will be 90 degree. That is why I marked as 90 degree symbol. Okay. See children, if we, so here this triangle, big triangle, equilateral triangle ABC is now divided into 2 right triangles, because one of the angle of this side of the triangle of this side, that is triangle ABD, here angle D equal to 90 degree. So we can consider right triangle ABD. If we have a right triangle, we can apply Pythagoras theorem. Why? Because here AD is one of the side of this right triangle ABD. You can take ADC also, doesn't matter, because AD is common for both right triangles. Okay, so either ABD or ADC. So I just considered ABD. That is the problem. That's all. Okay, so we have given a triangle ABC, equilateral triangle with the side equal to 2A. Okay, that means being it is equilateral, AB equal to BC is equal to AC. Okay, so by Pythagoras theorem, you can easily get its answer. By Pythagoras theorem, okay, what is square of the hypotenuse? Here the hypotenuse is the side opposite to 90 degree, that is AB square. AB square is equal to sum of the squares of other two. Other two side is AD and BD is a second side. So it's a square, that is AD square plus BD square. Okay, but what we need, AD is the altitude, right? Okay, so we need AD. So for that I am writing this equation with respect to AD square. Okay, so for that, that is AD square equal to, okay, I am taking this BD to this side. So here AB square minus BD square, okay, equal to AD square. Okay, so I am writing AD square in LHS, so I am taking this to RHS. So AB square minus BD square. This is AD square. AD square is square of the altitude. Okay, so we can substitute the values. That means here AB square, AB is that is length of one side. Being it is equilateral, you can write this, all these 3 sides are 2A, that is given. Length of each side of the equilateral triangle is 2A. Okay, so being it is AB is one of the sides, so 2A whole square minus, how can we substitute for BD? See children, from the figure BD, okay, is a part of BC, and I already told for an equilateral triangle, perpendicular, that is the altitude and median are the same. That means D is the midpoint of BC. Okay, since D is the midpoint of AC, implies BD equal to DC. Understood? BD equal to DC Or can you write this BD equal to half of BC? Half of BC? BD is half of BC. Or BD equal 2 times BD equal to BC. Anyway, you can write. Okay, so here we can take half of BC because length of BC, the another side of the equilateral triangle, its measurement is 2a. So we can substitute for BC as 2a. Okay, that means in order to substitute here BD, being BD is half of BC. Okay, so half of BC is 2a is given. So 2 get cancelled. So BD equal to A. So that means since here D is the midpoint, BD, this length will be A. This 2a is the whole length, 2a. So its half is A. So A square, because BD square is A square. Point is clear, children? Okay. So here 2a whole square, 2a whole square means 4a square, 4a square, ab whole square is a square b square. So a should be get squared, so 2 square is 4, a square is a square. Okay, minus a square, so you can subtract being these two are like terms, 4a square minus a square, coefficient of a square is 1, so 4 minus 1, 3a square. What is this? In the LHS we have AD square. But we need AD, so in order to get AD from AD square by taking the square root, okay, square root of 3a whole square. Understood? Root AB, two factors, 3 and a square. What is root AB, children? Root AB is root A into root B. Okay, root A into root B. So, root 3 is root 3 itself. Okay, because 3 is not a square number. Okay, but root of A square means this root, square root and A square get cancelled. So, you will have root 3 into A. A is not in the under the square root. Okay, it is free from the square root. So root 3 into A is the length of one of the altitude of an equilateral triangle of side 2A. Okay, in the same way you can get all the altitudes. Okay, even if the sides are different, you just continue in this manner, so you can easily get the altitude of any equilateral triangle with any side. Okay, so this is all about the sixth problem. Now the seventh question. Prove that the sum of the squares of the sides of the rhombus is equal to sum of the squares of its diagonals. So here we have a rhombus ABCD. Okay, and here the sides, we know that what is the property of a rhombus? The sides are equal, that is AB equal to BC equal to CD equal to AD, being it is rhombus. Okay, this side should express in terms of diagonals. That means we have to draw the diagonal, that means AC and BD intersect at the point O. Diagonals means the line segment joining opposite vertices. So, A with C and D and B. Okay. And we know the sides, the property of sides of a rhombus, all the sides are equal. And what about the property of the diagonals? Diagonal property of a rhombus, do you remember that? It's very important property. Diagonals are not equal. It's a very confused area. Diagonals of a square and rectangle are equal, but in case of rhombus, diagonals are unequal. But it has other two very important property. Diagonals bisect each other. They are the perpendicular bisectors. One of the diagonal divide the other equally at 90 degree. That is the meaning of perpendicular bisectors. Okay, which means here the diagonal BD divides AC equally. That is AO equal to OC. And at the same time, AC divides BD equally. That means OD equal to OB. Okay, perpendicular bisectors. They are dividing at 90 degree. That means you can see here 4 right triangles. Okay, that means AOD, AOB. Okay, here DOC as well as BOC. So, you can see 4 right triangles. What we have to prove? We have to prove that the sum of, to prove that, okay, prove that AB square plus BC square plus CD square plus AD square. What is this? This is the sum of the squares of the sides of the rhombus should be equal to sum of the squares of its diagonals. Diagonals are AC and BD, sum of the squares of its diagonals. This is what we need to prove in this question. Okay, for that we have all the required things, because we already explained it is divided into that. Now the whole rhombus is divided into 4 right triangle. Okay, that means you can apply Pythagoras theorem. If we have right triangles, definitely you can apply Pythagoras theorem. So in order to prove this, we are applying Pythagoras theorem. Okay, so I am applying Pythagoras theorem on this triangle AOD. Okay, and triangle AOB, all these 4 triangles. Okay, so consider right triangle AOB, AOD, DOC and BOC. Okay, by Pythagoras theorem, okay, yes children, in first triangle AOD, the square of the hypotenuse, the angle opposite to the 90 degree is the longest side. So AD square is equal to sum of the squares of other 2 sides, AO square plus OD square. Okay, and second, CD square is equal to DO square plus OC square, DO square plus OC square, and in the third triangle, this is the hypotenuse, BC square is equal to OB square plus OC square, this side and this side, and the fourth triangle. Okay, that is AOB, AB is the hypotenuse, AB square equal to AO square and OB square, AO square plus OB square. Okay, we can mark this as equation number 1, 2, 3 and 4. Okay, see, in the required proof, we should get the LHS in terms of sum of the squares of these 4 sides. See this in 4 equations. If you add ABC, children, what all things here, children? AB, AD square, CD square, BC square, AB square. All these are the squares of the sides of the rhombus. So what to do? We are going to add all the 4 equations. Okay, so 1 plus 2 plus 3 plus 4 implies we are going to add, that means AD square plus CD square plus BC square plus AB square. All these 4 are the sides of the rhombus. Next, we are adding the RHS of these 4 equations, that is from the first RHS, okay, that is AO square plus OD square, okay, plus OD square plus OC square, RHS of the second. Again, third one OB and OC, OB square plus OC square, and the fourth one AOOB, AO square plus OB square. See children, here in RHS, big RHS, 8 terms should reduce into 2 terms. Here in the required proof, we have same LHS is okay, sum of the squares of 4 sides of the rhombus, but in RHS should reduce into 2 terms, and these 2 are the squares of the diagonals. Okay, so in order to reduce this into this form, we are applying the properties of the diagonals, because they are the bisectors. Okay, AO equal to perpendicular bisectors. Okay, so AO equal to OC. Okay, so in place of OC, first we can consider this diagonal and its half bisect AO and OC. So I am going to substitute OC in terms of AO. Okay, that is the first step. Here I am going to make any change for this AO. I am reducing OC in terms, so I am going to write OC in terms of AO. Okay, see children, here OC, so AO square. Okay, here another OC, so AO square, and one more AO square. So 1, 2, 3, 4. So can we write this as 4 AO square? Okay, why? Because here we have AO equal to OC. We applied this result. And another one, OD can be equated to OB. OD and OB are the same perpendicular bisectors each other. Okay. So here OD I am going to make any change in OD square. So 2 OD square. But OB can be written as OD square. Here also OB square. So OD square. So 1, 2, 3, 4. So 4 OD square. Idea is clear. So now we have reduced this RHS into two terms. But what is the answer here? Not in terms of AO square and OD square. Okay, how this 4 AO square should reduce into AC square. Okay, for that children, here can you write this as 2AO whole square? Because as I told, AB whole square is A square B square, isn't it? Okay, AB whole square. So if you square this, 2 square is 4, AO square is AO square. Okay, so this is very important step. 4AO square should be rewritten as 2AO square. Why? Because in the next step we know we should get AO. We have to replace AO and OD. Okay, so if we can write this into 2 times AO, what is 2 times AO from the figure? AO and OC are the same. So if you write this is also AO plus AO, 2 times AO is AC, big, this diagonal. Okay, so next step I am going to replace 2AO with the AC. For that you have to write this in terms of 2 times OD whole square. Point is clear? That means 4 OD square should write in terms of 2 OD whole square. Doesn't matter children, all are equalities. Okay, we are writing the same value, okay, without changing its value. Okay, 4 AO square is equal to 2 AO whole square. Okay, so in the next step, this 2 AO together will make the first diagonal, that is AC. So you will be getting this is equal to 2 AO is AC and square. Okay, in place of 2 AO from the figure, 2 AO equal to AC. Okay, this whole line segment, and the same time here OD, 2 OD. See, this OD equal to OB. So this is equal to 2 times OD, that is DB. 2 OD equal to BD. Okay, that means here in place of 2 OD you can write BD, the second diagonal, BD square. This is the proof. Okay, that means now we have in the RHS, we reduce that 8 terms into 2 terms, and those 2 terms are the squares of the diagonals of the rhombus. And in the RHS part, sum of the squares of the sides. That is what we need to prove. Okay, that means we have proved the sum of the squares of the diagonals equal to sum of the squares of its sides. Now the 8th question. Here O is the interior point of triangle ABC such that OD perpendicular to BC, OC perpendicular to AC and OF perpendicular to AB. We have to prove 2 results. Okay, so first we are going to solve the first one. Okay, we have to prove this big result. Okay, see OA square, OB square, OC square. Okay, if you add the squares of all these 3, that is OA, OB, OC. Those terms are not there here. Okay, so in order to get OA square, OB square, OC square, see the figure children, you will get to OA only when you join this O and A. Okay, that means OA, OB and OC. And OF perpendicular, OD perpendicular and OE perpendicular to AC. Okay, so these are the terms, ideas given in the question. Okay, so we can continue children. Since it is perpendicular means there is a scope of applying Pythagoras theorem. Understood? See children, for that which triangle to be considered? Here the answer should come in the terms AF square, BD square, CE square. Okay, see children, which are the sides? AF square, okay, BD square and CE square. Okay, so in order to get AF square, see children, this is AF square and this is 90, OF is perpendicular to AB, so this angle is 90, so which is a side opposite to the 90 degree? OA, and that is the hypotenuse. This is a way to find out the hypotenuse of a right triangle if we have so many right triangles in a figure. You see that which is a side opposite to 90 degree. Here this is 90 degree, being OF is perpendicular to OAB, so AO square. So we are applying the Pythagoras theorem over this AFO, right triangle AFO. And next one, we need OB square and also here we need BD. Okay, so for that we can consider this right triangle BDO. So we will have the equation in terms of BD square and a BO square. And the CE, we should need CE, and OE, definitely OE. So we are going to consider this right triangle. Idea is clear? Okay, and we are applying Pythagoras theorem upon these three right triangles. Okay, so by first applying Pythagoras theorem, so consider these triangles, consider right triangle AFO, then BDO, and third one CEO, right triangles, these three by Pythagoras theorem. What is it? OA square equal to, this is hypotenuse. Okay, so its other sides OF square plus AF square. Okay, and the second right triangle, what is the hypotenuse? OB. OB square equal to BD and OD. BD square plus OD square. And the third right triangle CEO, this one. So its opposite side, this hypotenuse OC square. OC square equal to OE square plus CE square. This is equation number 1, 2 and 3. Then what to do children? Here see the proof. What we need to prove? That means OA, OB, OC. We have to add. Okay, that means OA square plus OB square, OC square should come only when we are adding equations 1, 2 and 3. Okay, so that is the next step. We are going to add equation 1 plus equation 2 plus equation 3 implies OA square plus OB square plus OC square equal to RHS. Okay, we are adding the first RHS OF square plus AF square. Second one BD square plus OD square. Okay, and the third RHS, that is OE square plus CE square. Okay, we added all the three RHS and all the three LHS. See, then look into the result. Okay, we should get only AF, BD, CE only come in the RHS. That means we have to take all the remaining three terms to LHS. That means we have to keep this AF square here, okay, BD square here, okay, and CE square. And I am taking this one, okay, OD and OF to LHS, RHS to LHS, so negative, okay. OF square become minus OF square. So along with this 3 terms already there in LHS, okay, implies OA square plus OB square plus OC square minus OF square. Here OD square when come to LHS minus OD square. This OE square minus OE square equal to the remaining terms AF square plus BD square plus CE square. This is the required proof. Okay, just rearrangement. Okay, now the second result. See, AF square plus BD square plus CE square equal to AE square CD square plus BF square. Okay, so you will get this answer very easily from the first result. In the first result here, this 3 AF square plus BD square plus CE square, we have this big expression. Understood? And from this we need this same in the LHS. Okay, one side should be AF square and BD square and CE square. That means there is no change in the RHS of the first equation, and I am making change in the LHS. Okay, that is this big expression. If you can write in terms of AE, CD and BF, this 8 terms, okay, not 8, 6 terms should reduce into 3 terms. Okay, see children, for that, the question is clear children, we should get this in terms of AE, CD, BF. See the given figure. We considered the shaded triangles first to get the first result, and in order to get the second result, you just concentrate the remaining 3 triangles. Okay, they are also right triangles, okay, because 90 degree, both sides are 90 degree each. Okay, that means if you consider this right triangle, that means triangle AEO, this one, AEO, you can see that AE comes in that triangle. Okay, AE, because we need AE. Okay, that means you can replace here the 90 degrees this. So this side OE is the hypotenuse. Okay, so this AE square will be OA square minus OE square. This is what I said children. In triangle AEO, see children, in triangle AEO, this triangle, red triangle, okay, here children, here the AO is the hypotenuse, AO square equal to AE square plus OE square, sum of the squares of these 2 sides. Okay, and from this what will be AO square minus OE square equal to AE square. That means in the LHS, okay, AO square and OE square, this one minus OE square. That means here AO square minus OE square. And this together we are going to write this as AE square. Okay, so 2 terms reduced into 1 term. Okay, in the same way, if you consider this right triangle O or BFO, OB is the hypotenuse. So OB square equal to OF square plus BF square. Okay, we need BF square. Okay, so BF square is equal to this, you should subtract this OF from the hypotenuse. See children, in the Pythagoras theorem, square of the hypotenuse is equal to sum of the squares of other 2 sides. So how can we write the same Pythagoras theorem in terms of the sides? So square of this one of the side is equal to, you should subtract the other side from the hypotenuse. Okay, being here BF is not the hypotenuse. So how can we represent using Pythagoras theorem BF square? BF square is equal to the hypotenuse, you should write first OB square minus the other side minus, that is OF square, that is OB square, this side minus OF square is BF square. That means what is that? OB square is here. Okay, OB square minus OF square is here minus OF square. So this is equal to, okay, what is it? BF square. BF square. Idea is clear? Okay, for getting the second term, I am grouping OB square minus OF square. Okay, OB and OF. Okay, and the third triangle, this red triangle we are considering to get the second answer. Okay, here we should get answer in terms of CD square. Okay, CD is not the hypotenuse. Here the hypotenuse OC. Okay, so in order to get the other sides, represent the other side, CD square equal to OC square minus OD square. Okay, other side should subtract from the hypotenuse. So hypotenuse is OC square minus OD square. See children, OC square is here. Okay, so plus OC square, okay, minus OD square. Okay, here what is it? OD is OC square, okay, and OD square minus OD square. Okay, so this will make, what is it? CD square. Okay, and what is in the RHS? RHS is same as the here AF square plus BD square plus CE square. Okay, from the first result you can easily reach into the second result. Just need a rearrangement. That means for that we considered the three right triangles and we applied the Pythagoras theorem. Here we applied the Pythagoras theorem not in terms of the square of the hypotenuse. We just applied the square of the other side, one of the side of the right triangle, that will be equal to a square of the hypotenuse minus the second side. Okay, that is what we have got here. OC square is the square of the hypotenuse, but we need in terms of CD square, one of the side. Okay, that is equal to OC square, square of the hypotenuse minus OD square. See children, OC square minus OD square is CD square. OB square minus OF square is BF square. Here OA square minus OE square is AE square. Looking into the required terms, accordingly you can rearrange the terms in order to get our result. Okay, so this is the second result. Now the ninth question. A ladder 10 meter long reaches a window 8 meter above the ground. Find the distance of the foot of the ladder from base of the wall. Okay, that is the question. So here we have ground and a window is there. Okay, so let it be ground. This line represents the ground and here comes the window, and being we are replacing window, some angle, okay, inclination will be there. We are not keeping in 90 degree. Okay, suppose from at this point, okay, we are placing the ladder towards the window is there. Okay, so we can join the base of the what is it, ladder. This here comes the base of the ladder to the top of the window. The window is there. So being this window and the ground will make 90 degree. Okay, so we can here mark 90 degree. So the position of the window A, here the ground and the base, that ladder, this perpendicular and the ground is AB, and here comes the foot of the ladder. So definitely this triangle ABC will form a right triangle. Okay, so what is given? Here this window is 8 meter above the ground. Okay, and the length of the ladder, this is the ladder. Okay, this is the ladder. Okay, and its length of the ladder is 10 meter, that is given. And what is asked? The distance. Okay, that find the distance of the foot of the ladder. This is the foot of the ladder here. Okay, from the base of the wall. Okay, okay, from here to here. That is BC is asked. Okay, from the foot of the ladder, base of the window. Wall, this here wall, usually we are placing the window on the wall. Okay, so base of the wall is B and the foot of the ladder is B. So what we need? BC, the distance. BC is needed. So we can apply Pythagoras theorem. Okay, so by Pythagoras theorem, okay, square of the hypotenuse, the side opposite to the 90 degree, that is angle B is AC square is equal to AB square plus BC square. In order to get to this square of the hypotenuse, we are adding the sum of the squares of other two sides. If you want to represent one of the side, you have to subtract this from the hypotenuse. Okay, that is very important. So we are going to represent, we need BC, so we can write this in terms of BC square. Okay, so what I said, we have to subtract, okay, this side AB square from the square of the hypotenuse. Okay, so this is the way we can apply the Pythagoras theorem for the other two sides. Okay, in terms of other two sides. Okay, so AC square is 10 square minus 8 square, that is 100, 10 square is 100 and 8 square is 64, that is 36. This is BC square and we need the distance of the foot of the ladder from the base of the wall, that is BC. Okay, that is root of 36. Okay, in order to get BC, you have to take square root on both sides. So root 36 and square root and square sign get cancelled. So BC, that is equal to 6 centimeter. So this is 6 meter. Okay, 6 meter. This is the distance of the foot of the ladder from the base of the wall. Simple question. Now the 10th question. A gay wire is attached to a vertical pole of height 18 centimeter, is 24 meter long and has a stake attached to other end. How far from the base of the vertical pole should the stake be driven so that the wire will be taut? Okay, so from the question it is clear, on a ground a vertical pole is placed and a gay wire is attached. One end of the gay wire is at the top of the vertical pole and other end is on the ground and a stake is attached at the other end. And the length of the wire is 24 centimeter is given. Okay, and that should be come without any doubt, that without any problem, okay, from the vertical pole to the ground. Okay, and for that, what will be the distance from the base of the vertical pole to the stake at the other end? So that means we should get this distance. Okay, one is kept at the top and the other end is on the ground. Okay, so we know that this vertical pole and ground will make 90 degree. Okay, so AB is the height of the pole and that is given as 18 meter. And this can be C, this vertex is C. So AC is the length of the wire, that is 24 meter is given. So we need BC. So it form a right triangle. So definitely we can apply the Pythagoras theorem. Okay, and BC is not the hypotenuse. So we should get the square of one of the side of the right triangle. That means square of the hypotenuse minus AB square, square of the other side. Okay, so it's very simple problem. Okay, in right triangle ABC by Pythagoras theorem, BC square equal to AC square minus AB square. If you want that result, that Pythagoras theorem, that you can write, and from that you can write this step also, that doesn't matter. So we are going to write the values of AC. The length of the wire is 24 square minus AB length, height of the vertical pole is 18 meter, that is given 18 square. So 24 square is 576. Children, better to learn the square of numbers from 1 to 30. That will help you to get the, make your calculation easy. Okay, yes, 18 square is 324. So we can subtract, okay, that is 576 minus 324. Okay, 4 to 6 2 and 2 to 7 5, 3 to 5 is 2, that is 252. This is what BC square. We need BC, so we have to take the square root, so it will reduce into BC, and square root of 252. We know that no square number end with the digit 2, 3, 7, 8. Okay, that means this being this 252 end with 2 means this is not a perfect square. But how can we get the square root of this number? By prime factorization. Okay, so we are going to do prime factorization of 252. Being it is even, you can start with the 2. 2 into 1 time, 2 in 5, 2 and remainder 1. So in 12, 6 time, 2, 1, 26, again 2. So 6 and 2 in 6 3 times, 63 divisible in 3. Okay, 3 in 6 2 times, 3 in 3 1 time, and 21 you can divide with the 3. 7 3s are 21. Prime number comes. So we can stop the division. So we can express this 252 in terms of the prime factors. 3 into 3, 2 into 2, and 1 7. And to get the square root, you can take 1 from each pair. So 2 from this and 1 3 from this. So we please don't put again square root because we have taken 1 from each pair. But here being 7 occur not in pair, we have to write 7 in under square root. So under square root. Okay, so 2 3s are 6 into root 7 meter. This is what is asked. This is the distance of between this base of the vertical pole, and here the stake is kept at one end of the gay wire. That means BC is equal to 6 root 7 meter. So this is all about the 10th question. So the remaining problems we will solve in the next video. So thank you children. Thank you for watching and supporting my channel. Thank you all.